topic that, it's not that it's such a hard topic, but it is a topic that people struggle with for various reasons. I do want to show you what I'm talking about here. There's something called the law of signs ambiguous case. The law of signs ambiguous case is where you have, let's say, a picture like this. It's not drawn to scale. 25, 19, 40 degrees. So there's an unknown angle. And it might be that it's impossible to even make a triangle that has 25 and a 19 across from the 40. Sometimes it's not even possible. Sometimes it's possible to do it in two different ways. And in this case, there is a way to do it. There are two ways to do it. One way is to stick it is for x to be 58 degrees, or there's a way it has the same situation with a 40-degree angle, but it looks like that, and x becomes 122 degrees. When this happens, it's called the ambiguous case, and we want to look at, is there a shortcut for determining when it's possible, or when it's impossible, or when there are two possibilities? The way we answer either of these questions, or let's say I just have this question with sort of ambiguously drawn. Well, you would just do the law of signs. 25 over sine x equals 19 over sine 40. Eventually I get sine x equals 0.8458. We get a reference angle of 58 degrees. If we use quadrant 1, we get the acute answer. And if we do 180 minus 58, we get the obtuse angle. So I guess the question is, why wouldn't this just always happen? Well, here's an example. It looks like the same kind of deal. 10 over sine x equals 12 over sine 58. Eventually leads us to sine x equals 0.7067. So reference angle is 45 degrees. And 45 degrees is one of the answers. But if you try to find the other answer, you say, well, why don't I just try to just go like that? If you actually try to find the other answer, you get x equals 180 minus 45, which is 135. You say, okay, so what's wrong with that? Well, what's wrong with that is that 135 plus 58 is already bigger than 180. So we would actually reject this answer, and there would only be one answer to this question, just the 45 degrees. So one way to tell whether your obtuse answer is actually a valid answer is if the two angles that are known add up to less than 180. If you go back to here, this 122 is okay, because 122 and 40 is 162, which is less than 180. Here's a situation that if I use the law of sines, 12 over x, I get sine x is equal to 1. And when that happens, x equals 90 degrees, only 90 degrees. So that would be an example where there's just one answer also. If we get sine x equals 1 at some point, it's just one answer, one right triangle. Again, I'm drawing these almost looking like equilateral triangles, so there's no hints as to what's going on. In this one, 10 over sine x equals 4 over sine 70, and we get sine x is equal to 2.3. So when that happens, it's actually not possible to create a triangle that has these three things. Just like you can't make a triangle that has, sides 10, 1, and 1. It's just not possible to create it. Well, it's not possible to create a triangle that has 10 and 4 opposite a 70-degree angle. Sometimes this is phrased as a word problem. So angle A is 54 degrees, and side B is 20 degrees. So I'm going to make a diagram. I'm going to put A here. I'm not going to put B. Point B is somewhere on this line, but where exactly, I'm not sure. So I'm going to go like that. But angle A is 54 degrees, so I can draw that. And side B, at point B is somewhere, I don't want to commit to where it goes, but this is definitely side B then. So that's given. So this 54 is given and the 20 is given. So it's kind of like I think of it like a pole that's in the ground and it's at this angle and it is this length. And side A is 18. Now I didn't draw this in, and I'm going to draw it in sort of an ambiguous way. I'm going to go like that. Because I don't know if it's possible even, or if it's possible two different ways. So I draw it kind of ambiguously, sort of like floating out here. Then I do the law of sines, and somewhere over here is where the angle is going to end up. 20 over sine x equals 18 over sine 54. Reference angle ends up being 64 degrees, so I get two answers, 64 and 116. Now the 64 is always going to be one of the answers, but for the 116 you have to check, does it add up to less than 180? Yes, it adds up to 170 with 54, so there's actually two possible answers. Now there is kind of a shortcut or a way to tell whether there's going to be, sometimes they just want to know, is there one answer, no answers, or two answers. So here I have an example where A is an acute angle. We'll analyze this case first. In order for there to be two answers, what has to happen, it's a little bit hard to visualize it. Sometimes I imagine like a kid on a swing. And if he's swinging, if when he swings he doesn't reach the bottom ever, then his swing never forms a triangle. So that's one possibility. A could be too short. Another possibility is that A is just long enough that it just grazes the bottom. Then you'd have one answer. A third possibility is that A would hit here, and let's imagine there's like water here. So A would go through the water, and that would be one of the answers. And then A would come through around this way, and that would be the other answer. So I'd have this obtuse triangle, but I'd also have this acute triangle. That would be two answers. A trick to figuring out which of those three cases it is to draw this line, which I'm going to call H. It's the height. And that height is going to be B is the hypotenuse of this triangle times sine A. So you can calculate out B sine A. And whatever that is, if A is less than B sine A, there's going to be no triangles. If A is equal to B sine A, it's going to be one right triangle. Now the only other case is, what about the time where there's one acute answer? And this one's also pretty hard to visualize, but the idea is that if this A length is so long that the kid's swing goes through here to get one acute answer, but when he swings around, it passes this entire line and ends up over here, then this angle wouldn't be part of it. So for there to be two triangles, A also has to be less than B. If A is bigger than B, this line's so long, you'll definitely get an acute angle, but you won't get the obtuse one. So the way you get two triangles is A is less than B, but bigger than B sine A. And those are like the three scenarios when A is acute. Oh, I guess I don't have. If A is bigger than B, that's sort of the fourth. then you'll get one acute triangle. So those are all the things that could happen when A is an acute angle. It's also possible, although it's much easier actually, if A is an obtuse angle, or weird, here's side A, like that swing thing. So for this one's a lot easier because if A is less than B, it basically is going to swing down and not make any triangle with this side here. So that's 0 triangles. But if A is greater than, this would also have A was equal to B. If A is greater than B, then this happens. It hits it once, but it's never going to hit it on that other side. So that'll be one acute angle. Of course, if this angle is obtuse, the only other angle would need to be acute because you can't have two obtuse triangles. Two obtuse angles in the same triangle. I wouldn't recommend memorizing this, but this is sort of a flow chart with all the possibilities. If angle A is obtuse and A is less than B, you have no triangles, but if A is greater than B, there's going to be one triangle. And B would be acute, although it would be an obtuse triangle because it's already got angle A being obtuse. If A is acute and A is greater than B, you're going to get one triangle. B is going to be acute. There's an angle C also, and that might be obtuse, but we were not saying anything about that other angle now. And then if A is less than B, that's like the swing situation. It all depends on how big A is. If A is equal to B sine A, then it just grazes the bottom, makes a right triangle. If A is less than B sine A, that's when you have this situation. It doesn't hit the bottom at all. And then you have this thing, the ambiguous case. That happens when A is less than B, but bigger than B sine A. If it's between those two things, you're going to get two triangles, one with B being an acute angle, and one with B being an obtuse angle. So this is a chart I could imagine putting on a test. You're given different values of angle A, side A, and side B. They want to know how many triangles, either going to be 0, 1, or 2. Now I'm going to start with the obtuse ones because when A is obtuse, it's real easy. When angle A is obtuse, if A is greater than B, in this case, 50 is greater than 47, there's going to be one triangle. But if A is less than B, there's going to be no triangles. And in this one, A is greater than B, so there's one triangle. So that's the obtuse case. For the acute case, it's useful, the acute case where A is bigger than B, that's just going to be one triangle, where angle B is acute. It might be obtuse triangle still, but angle B, I'll just make a note, B is acute. These other ones, of course, all of them, B is acute, because angle A is already obtuse. Okay, now we've got these other two questions. So for this one, this top one, 50, 400, 300, A is less than B, so we might have 0, 1, or 2. I'll calculate the height by doing, the height is always A, it's always B sine A, sorry. And in this case, it ends up being 306. So 306 means that A is actually less than the height, so there's no triangles because we have this situation. There's the height, and A is just small, so it doesn't quite make it. Now in this one, A is less than B, so we might have 0 or 1 or 2. We calculate out B sine A, and we get 321. So because A is between B sine A and B, that's when we have two triangles. One with B acute, obtuse. I should probably also throw in one like this. Angle is 30. Wait a second. This question I did here, that's the one I want to do. This is not an obtuse angle, so forget. Got that. So this is 38 and 9. It's 30, 18 and 9. Now this is all making sense. So in this case, we have an acute angle. We have A is less than B, so we may have 0, 1, or 2, depending. And when I do B sine A, I get 9. So when A is equal to the height, we get 1, and B is a right angle. And that's the ambiguous case. It's kind of confusing. People really struggle with it on tests and things. So you just want to study the cases and do try to visualize, especially with the acute angle, the idea of the interaction between the height and between whether A is too small or whether A is like just the right size, or whether A is bigger to get 2, or whether A is so big that it doesn't make it at all. Those are like the different cases between having one acute angle be an acute or an obtuse or a right.